The next couple examples have to do with converting between atoms, moles, and mass. We're going to work these exactly like we did the unit conversions between metric units or metric and English units. The conversion factor to go back and forth between atoms and moles is Avogadro's number. So we use 1 mole is 6.022 times 10 to the 23 atoms. To convert back and forth between moles and mass, we're going to use the molar mass that we have in the periodic table. So 1 mole is equal to whatever that mass is that's given for that element in the periodic table. We can go directly between moles and atoms or between moles and mass, but if I need to go from atoms to mass or in the other direction, I have to go through moles first, and so I have to do it in 2 steps. So let's look at a couple of different examples. Alright, so our first example, we want to know what is the mass of 0.829 moles of helium. In any of these examples, I wrote down the conversion factors that we're going to use to make the video a little bit faster. Right, so 1 mole of helium is 4.003 grams, and I got this number from the periodic table. So we start by writing down what we're trying to convert, in this case 0.829 moles. And then for my conversion factor, I want the moles to go in the denominator so that it'll cancel with the moles that I have in the unit I'm trying to convert, and then so 4.003 grams will go in the numerator. So I have 1 mole. So the moles will cancel. I'll be left with grams. And when I multiply that out, my answer is 3.32 grams. All right, let's do another example. So in this case, we want to know what is the mass of a given number of atoms. So this is going to be 2 steps. So I'm going to need to go from atoms to moles, and I'll use Avogadro's number to do that. And I'll go from moles to mass, and for that, I'll use the molar mass. Again, this number came from the periodic table. So let's write down what we're trying to convert. 7.29 times 10 to the 22 atoms. This is going to be a 2-step conversion, so I left 2 spots for it. So in the first one, I want to get rid of atoms, so I find the atoms in my conversion factors. So Avogadro's number will go in the denominator, and then 1 mole will go in the numerator. All right, so in this case, our atoms cancel. I've got moles, so now I want to use my other conversion factor, so I've used that one. We can cross it out. I want to use my other conversion factor, so I've got moles in the numerator, so I want to put moles in the denominator, so the 1 mole will go down here, and then the 10.81 grams will go in the numerator. All right, so our moles will cancel. I'll be left with units of grams, which is good. That's a unit of mass. So I'll multiply 7.29 times 10 to the 22 times 10.81 and divide that result by 6.022 times 10 to the 23rd. Remember, when you enter this number in your calculator, be sure to either use parentheses or use your exponent button so that the calculator knows that that is one whole number. And when I do that, I get a value of 1.31 grams. If you get a really absurdly high number whenever you're calculating a mass, it probably means we've got this unit conversion possibly upside down, or that you made a mistake using the order of operations in your calculator and you multiplied by 10 to the 23rd instead of keeping it with the 6.022 and dividing by that whole thing. All right, let's do one more example. All right, in this problem, we want to know how many atoms there are in 25.8 milligrams of calcium. Now in this problem, we've added the additional wrinkle that I haven't given you the mass in grams, I've given you the mass in milligrams. So in addition to the other conversions that we've been doing so far, I need to get my milligrams into grams. So we'll need to do this in 3 steps. So I'll need to convert from milligrams to grams. I'll then use the molar mass to go from grams to moles. And then finally, I'll use Avogadro's number to get from moles into atoms. So if you write down what we're trying to convert, 25.8 milligrams. And then we have a 3-step conversion problem. So I've got milligrams, so I need to get milligrams in the denominator, and then 10 to the minus 3 grams will go in the numerator. All right, now I have grams in the numerator. I've used that conversion factor. So now I need to get grams in the denominator. So I'll use my molar mass, and .08 grams will go in the denominator. I get 1 mole in the numerator. So now I've got moles in the numerator. I now need moles in the denominator. So I'll use Avogadro's number, and I'll end up with 1 mole, and then all right, so let's check and make sure all our units cancel out. So milligrams cancel, grams and grams, moles and moles. I'll be left with atoms. So we'll multiply everything across the numerator, then divide that by everything in the denominator, and the result that I get is 3.88 times 10 to the 20 atoms.